Hello everyone, back to our latest lecture session I guess. So we introduced ourselves to a new software, VMINTEQ, and what does that give us an idea about, or how does that help us? It's going to help us in solving multiple equilibrium related scenarios, right? What are the concentrations of your relevant compounds at your equilibrium, let's say, right? But for that, what do we need to be able to develop? We need to be able to identify the components and also be able to give or specify what is the total component concentration going to be, right. So, in that case, in the previous lecture I believe we looked at a case of adding a single acid to a water. So, the next case we are going to look at, again a simple case I guess, is going to be adding a single base to water, right. So, again the whole point of this class is not just to understand the system, but also to be able to intuitively come up with the solution now, right. So, once you have relevant background, you should be able to hopefully guess at the relevant answer. So, that is something again we are going to try to do in this particular class or session again, right. So, let us see what we have here. So, the next example I guess we are going to have is that we are going to add a single base, and what is that in this case? So, earlier we looked at the single acid. So, we are going to use the conjugate or similar acid here, and it is going to be NaAC, or I guess sodium acetate, and we are going to add it at 10 power minus 3 molar, and I want to know the pH and the concentrations of all and any other compounds that are going to be in solution, right. So, earlier we had an acid and we looked at calculating the pH. I think we did a relatively decent job with respect to estimating the pH. Same case here, first let us try to estimate the pH of this solution now, right. So, first it is going to be a test for us I guess. So, let us do that here. So, we are adding 10 power minus 3 molar, right, not too strong and not too dilute either, but the total is 10 power minus 3 molar, and we are not adding the acid here, we are adding the base, right, NaAC let us say, right. So, keep in mind now that the pKa value is around 4.7. So, let us look at the pH let us say, right, and we know that it is going to be something like this, and if it is going to be something like this let us say, and here is 4.7. So, if you are adding base to water, first the pH should increase. So, it should hopefully be greater than 7 let us say, right, it is going to be hopefully greater than 7, and what else can we look at let us say, and but if it is around 7 though or greater than 7, you see that most of it is going to stay as AC minus and little of it will probably be as HAC, 4.7 and 6.7. So, very little of it is going to be staying as HAC. What does that mean? So, HAC and AC minus and H plus, right. So, when you are adding AC minus to the solution, which is the case here, very little of it is going to stay as HAC, as in very little H plus is going to be removed from your solution, right. So, what does that mean? The pH is only going to slightly increase. So, let us say we are going to go with 7.2 maybe. So, this is my guess here, let us see, or let us check later on I guess. So, let us come back to what we have here. So, first what is our approach here? We always look at what are the species. What is our approach here? Let us try to regurgitate here. Species, we need to identify what are the compounds that are present at equilibrium in the solution, and for this you obviously need some background. And what is the background that we have? We have some background with respect to acid and base chemistry, right, and we already discussed the relevant aspects. So, we do not need to go in that in detail. So, we identify the species, then choose the components accordingly, then write the formation equations pardon me, and then come up with the tableau, and then the component balance equations, and then we come up with the equilibrium equations, and then finally solve them. So, obviously the VMINTEQ can bypass most of these, but you should at least be able to write the tableau or come up with the component balance equations, right. So, let us see what we have here. So, species now are going to be certainly H plus and OH minus, right. We are always going to have them in water. Whenever we have water, these are aqueous solutions, and then we have the deprotonated form AC minus, which is what we are adding, and we are going to have the protonated form HAC. So, you are not sure, so that is why I am going to have HAC here. I am not sure if I am going to have HAC or at significant levels, but I am going to go with having it, and obviously because I am adding sodium, I am also going to have Na plus. So what's the equation here, I guess, that we need to look at? NaAC will dissociate into Na plus plus AC minus, and AC minus plus H plus can go to HAC, right. So that's what we are more or less looking at, right. So these are our species here. So what are our components? So similar to the last case, we are going to choose. How do we choose the components? We always try to choose such that you are going to arrive at the solution earlier, and in this case we say always choose H plus. You can choose OH minus, but you will arrive at the solution later, I guess, especially if working out by hand, and especially if you look at VMINTEQ, I guess you would obviously try to choose H plus. Why? I believe H plus is listed as one of your components, right. So again, even if you are trying to work out by hand, it's always better to choose those components that are given as preset components in your VMINTEQ. So that's always a guaranteed way to arrive at your solution faster. So let's see here, the components obviously are going to be H plus, and then the thumb rule is most deprotonate form AC minus, and we are not done with that because we still need to form Na plus. We are going to go with Na plus, right. So now the formation equations, what are they? I guess I am going to list all my species here: H plus, OH minus, AC minus, HAC and Na plus, and let me look at that. So how many H plus do I need here? One H plus to form or is equal to H plus, H2O minus H plus is equal to OH minus, one AC minus will form one AC minus, and H plus plus AC minus will form HAC, and one Na plus will form my Na plus. So now I can come up with my tableau, and what's my tableau here, please? And here I am going to have the components H plus, AC minus and Na plus, and the relevant species here H plus, OH minus, AC minus, HAC and Na plus, and then here the recipe species. What did we add initially? We have the source compound for everything as NaAC, that is going to be NaAC naught. So even for that I am going to write that down, NaAC naught. How do I form that? Na plus plus AC minus will be equal to NaAC naught. So anyway, coming back here, so first I am going to write the components with respect to H plus from these formation equations, right. 1 H plus, minus 1, 0, 1, 0 and more critically 0 here, right. And AC minus 0, 0, 1, 1, 0 and again 1 here, and here Na plus is going to play no further role here, it is just a salt here. So 1 and 1, right. So obviously you can straight away solve for concentration of Na plus, right, if you apply here. So let us move on to this particular space here on the left hand side, and if I want to I can directly remove that particular variable from my unknown Na plus or Na total. I am going to do the component balance here, and I am going to start with Na. So Na total is equal to the concentration of Na plus at equilibrium, and that as I see is equal to 1 times NaC naught, NaAC naught, and that as I know is equal to 10 power minus 3 molar, 10 power minus 3 molar. So concentration of Na plus should be equal to 10 power minus 3 molar. So I am already done with that. So I can obviously again set up the relevant equations for H total, but what will H total be equal to, I guess, right. Let us just write down H total for now. H plus minus concentration of OH minus plus HAC, and that is equal to what now? There is no source, so that is going to be equal to 0. So that is the change here, I guess. But with respect to AC total, what are we going to see here? It is going to be equal to the concentration of HAC at equilibrium and also concentration of the acetate ion at equilibrium, and that is equal to 1 times concentration of NaAC not initial, that is equal to 10 power minus 3. So we can obviously solve for this. So instead of solving for this, let us go ahead and plug this in, and let me look at my estimate of around 7.2, right. So let us go ahead and plug this in. So we have Na total 10 power minus 3, H total is 0, acetate total is 10 power minus 3. So I am going to switch here, and edit list. Okay, I thought I plugged that in, I guess it's not 0.3, and the estate total was 0.001, right, 0.001, and I am going to add that to the list, right. I am going to check the list just to be sure. Okay, and what else? I think I need to add H total, A, B, C, D, F, G, H total, though I believe was, I'll add it to the list and then set it up to be 0 here, because H total, as we knew, was 0, right. It was just 0 there, it was just 0. And again back to main menu, and again I am going to add NA plus and NA, I guess I am missing something here, sodium, right, and that again was equal to 0.001, and I am going to add to that list, view edit list, 0.001, so on and so on, right. So that is what we have here, and back to main menu. So we need to calculate the pH. Ionic strength is not fixed and needs to be calculated, and the units are molal, right. I could have used millimolal and 1, I will do that later. And so I am now going to run the VMINTEQ, and let us see what we have. Okay, I guess I am slightly off from my particular value, looks like the pH is slightly higher, 7.8, and let us look at what the species are. Did we approximate the species well enough? So we did look at 5 species, I guess, right, 1, 2, 3, 4 and 5. So we did not list NaAC and NaOH, because in general they would be present at very low concentrations, and I guess that is what you would see here. Yes. So NaOH is present at very low concentrations, and even NaAC is present at very low concentrations. So some of the take home messages are ionic strength is again low, so that is why the concentration and activity should more or less be the same, because activity coefficients are going to be now negligible, not negligible I guess, they are going to be equal to 1. So that is what you see here, and let us look at species distribution. What will this give me an idea about? In what form is estate present as? So looks like almost 100% of it, almost anyway, is present as AC minus, right, and that is what you see here, and very little, less than 0.1% is present as NaAC and HAC, that is what you see here, right. And also Na plus is present almost 100% or more than 99.9% as Na plus, and very little is present as NaAC, right. So we are done with that for now. Again, this is what you expect. Why is estate AC minus so high in concentration? Because pH is far greater than pKa, right. So that is why you see that more or less all the estate or estate total is present as AC minus. So again, keep in mind that we have the pH versus ionization fraction graph, right, and we know that when the pH is exceeding pKa, what do you expect now? You expect that at equilibrium at that particular pH, when pH is greater than pKa again, you are going to expect that the proton, not proton, pardon me, the relevant acid is going to stay in its deprotonated form. And for the acetic acid, what is the deprotonated form? It is the estate ion, right. So that is what we see here, and as pH 7, or in this case 7.8 I guess, right, that is what VMINTEQ calculated, is far off from 4.7, which is the pKa of your particular acetic acid. So that is why almost all of your acetic acid is present in the deprotonated form, which is the acetate ion, I guess, right. Anyway, so estate total, most of it is an acetic acetate ion, and take home message is pH 7.8. So let us go back, I guess, and look at the other example that I have for today. So I am going to switch here. So I am done with this particular case. So we will look at the other example, and I believe the other example is such that we are going to add both an acid and a base. So earlier we add only one acid or one base. So this time though I am going to see to it that we are going to add an acid and a base. So we know that the source compounds or recipe species are 10 power minus 3 HAC and 2 into 10 power minus 3 NaAC. So you are adding an acid and you are adding a base at twice its concentration, and from our background we know that the pKa value is 4.7. So, the first aspect we need to do that is we need to, or we are trying to intuitively guess the answer, right. So, let us try to do that, I guess. So, here we have we are going to try to guess that, and we have relatively equal amounts. No, we have higher concentration of the base twice, right. So, we have the HAC and AC minus, but AC minus is in higher concentration. So, the first case that I can guess is that you are adding the same type of acid and its conjugate base. So, the pH is going to be nearer pKa, right, if you add same concentrations of acid and base to water. But here the pKa is 4.7, but you are adding more base. So, what would that be then, or what would the pH then be? It will be slightly higher than your pKa value. Again, if you add the same quantities of your acid and conjugate base, you are going to have your particular pH nearer to the pKa. But now you are adding twice as much of your base as your acid. So, what I am presuming is that the particular concentration, not concentration, pardon me, pH of your particular system is going to be higher, but not by great value when compared to your pKa. So, let us see why that is, I guess, right. So, here not why, just a basic explanation. So, pKa is 4.7. So, if we added them at equal quantities, we will have them at 4.7 pH, but if I am adding twice that and the concentrations are not too high but not too low either. So, I am going to go with around 5 maybe, pH 5. So, let us say our guess is going to be equal to 5. Why is that? Because I have higher concentration of base compared to the acid. So, again briefly let us set up our particular system, right. We are going to list the species, the components, and directly we are trying to go into write the tableau today, or this time anyway, and then we are going to set it up in VMINTEQ and let us check our answer, I guess, right. So, let us list our species. So, the usual species that you would expect are, what is it now, HAC and AC minus, and certainly H plus and OH minus, and then Na plus. So, we are neglecting the other minor species that we came across. I believe we came across NaOH and sodium acetate too, but as you see they were less than 0.1% of 10 power minus 3 molar. That means they exist at little to negligible values, I guess. So, anyway, HAC, AC minus, at least with our acid base chemistry background, we should be able to have HAC and AC minus, and H plus and OH minus, and obviously the salt Na plus. So, let us try to write down our components. What is going to change? Not much, because they are still the same. We are going to have H plus, AC minus, and Na plus, right. So, those are our 3 components. So, let us directly jump on to the tableau, and here I am going to have the species HAC, AC minus, and here it is going to be 1, 0, 1, minus 1, 0, 1, 1, 0, 0, 0, 0, 0, 0, 0, and 1. But here the issue is that we have 2 source compounds or recipe species. They are HAC naught and NaAC naught. So, we have 2 recipe species. So, H plus, that is going to be 1 here, and again acetate 1 and 0 here, and again here it is going to be 0, no contribution to NaAC, AC is going to be 1 and Na is going to be 1. So, first we need to have our H total. So, for VMINTEQ, what do we need to be able to specify, I guess? We need to specify the components, right, and the total component concentrations, which is what I am trying to calculate here, or we are trying to calculate here, right. So, H total, what is that equal to? It is 1 times HAC naught, and that is equal to 10 power minus 3 molar. And what about AC total though? That is equal to 1 times, and this is what we are looking at, is equal to what do I have here, HAC naught plus 1 times NaAC naught. And what are these 2 compounds? Where do we get that from? That initially these are the 2 compounds that we are putting into our system, right. So, now we have that is going to be equal to HAC naught is 10 power minus 3 plus 2 into 10 power minus 3, that's equal to 3 into 10 power minus 3, right. So, these are the two values or two components that I am going to plug in into my solution. The units are molar units here. So, switch. So, let us look at view edit list, and again the sodium Na plus is equal to 1 times NaAC naught, and that is going to be equal to what now? NaAC naught is 2 into 10 power minus 3 molar. So, I will switch. Now, this time I will switch to millimolar units, and I know that, and what is my particular value here please, and I know that the sodium was equal to, I believe, 2 millimolar, right. So, I will say add that to the list, and what else do I need to have? I need to have say key disappear, I guess. H total is equal to 10 power minus 3 and estate total equal to 3 times 10 power minus 3. Let us see if I can edit that list here. H total is equal to, and again the key, H total was equal to 1 millimolar, I believe, and estate was equal to 3 millimolar, right. So, this now the units were back to main menu, right. The units were millimolar. Let me again just check 3, 1 and 2, H plus is 1 and estate is 2. Let us check that again please. So, H total is 1 millimolar, right, 1 millimolar, and this is equal to 3 millimolar, and let us switch and check 1 and 3, right. We are on the right track. So, everything else seems in order, and I am going to run my VMINTEQ, and first aspect is well, that is bingo. We have pH as 5.042, and I believe we estimated to be around 5 or such. So, that was a decent guess there, and then we have the relevant concentrations and activities. Right here we have a slightly higher ionic strength, that is the reason why we see some deviation with respect to our activities, but still relatively dilute values. And again, major aspect to look at is the species distribution. So, Na plus is always mostly going to stay as its salt. So, Na plus itself. So, 99% of Na put in is going to stay as Na plus at equilibrium, and this particular table. So, as pH 5, right, the pH is 5, and we know that the pKa value. So, pH is 5 and pKa of this acetic acid is what now? 4.7. So, what does that mean? You are going to have slightly higher concentration of your acetate or deprotonated form, but still significant amounts of your protonated form. So, let us see if we have that. So, that is what we see here. So, 66% is as acetate or the deprotonated form, and we see that as the HAC or the protonated form we have 33%. Again, the total should obviously be equal to 100%, and that is what we see here. And so, we are done with today's class again. So, we were today able to again look at a few more examples, one with respect to addition of base, and then addition of both an acid and a base, and then estimating the pH, and then looking at the total component balance equations to be able to calculate your what do we say, pH using VMINTEQ. So, with that I guess I bid adieu, and we will meet in the next lecture session, and thank you.